But there's a number of good reasons why ZLD is going to become the wave of the future. And just several. Many of you are dealing with your NIPD's permits. You're noticing that the requirements are becoming more stringent. In some cases, it's almost impossible to meet those discharge requirements, and so you are forced to go into a ZLD mode. That is, you're not going to discharge your cooling tower blowdown, your RO reject or boiler blowdown to a stream or to the environment. You're going to recapture that water, reprocess, and use it internally. That second point, public scrutiny of the ethanol industry. You know, the industry is bashed continuously by people using too much water. Suggest to someone that they do a Google search and see how much water, Google, how much water does it take to make a gallon of gasoline? The EPA has a website, and it's around 1,900 gallons of water to process a barrel of crude. Those 42 gallons, when they translate into diesel and gasoline, you're looking at somewhere between 35 to 45 gallons of water for 1 gallon of a petroleum distillate. Compare that with ethanol at the industry average of 3. So when you talk about ZLD and saving water, this is very good news to people. Rick Vondra, who's here, he's the plant manager at Patriot, which we're going to talk about in a few minutes, went ZLD very recently. We talked to the EPA representative. He said this is what the agencies want to hear. They want to hear that plants are looking at ways to conserve water and to go zero liquid discharge. The other benefit of ZLD is it does conserve water. Besides not having to discharge, you're not faced with potential penalties and fines and issues with the state. You will also save water. If you design a plant from the start, a greenfield plant, you look at the water system, it's a challenge, but it's much easier to do that from the beginning than going into a plant that's been running that now needs to go ZLD, because you have to consider what equipment is there, what are the personnel capabilities, are there people capable of running those systems. A ZLD can be just as complicated as the ethanol process. You need good, sharp people, and those people are not on the street everywhere. This is a part of the market that finding qualified people is difficult. And of course, the budget realities, it's expensive. If you put in a ZLD, you're looking at several $1 million on the low side. There's plants that have spent $20 and $25 million for a full ZLD process. One of the key things, and you're going to hear our ZLD, we call it iZLD. Everything is I now, iPod, iPhone, iZLD. Well, that term I is for integrated, because it has to be integrated into the ethanol process. There are designs that have been overlaid into an ethanol plant where it's like they forgot there was an ethanol plant on the property. They put in a water system that there's no synergy between the two. So in your design, you need to make sure that those synergies are accounted for and utilized. U.S. Water has had quite a bit of experience in this. I have personally been involved in the past year with 4 plants that had designs that were not operational. I spent 4 months at one plant to get that design to finally work. During the first 2 months, I thought, this is not going to work. This is a $25 million plant. And this is not look good. We eventually got it to work. One plant I had some experience with, started up, the plant shut down, it's still down. It's shut down because of a poor water system design. So some people may think, well, I'll just copy what a municipal system has done. A municipal system, supplying water for a city, you have a nice predictable water supply. The public uses water regularly in the daytime, less at night. An ethanol plant or industrial environment, totally different. You have a demand system. You need water for that prop tank, or you need water for the cooling tower. That's a demand system that you need water now. And that system has to be robust enough to supply that water. Also, we push those systems much harder. We use coal lime softening, for example, and we push those much harder than a municipal system pushes the water for a community. Besides the original design, you also have to think about now implementation, because we're all in that room, we're excited, we have a design, this is what we're going to do, it's great, plant's done, now we're out there, let's start and let's actually make it work. And you need someone who's capable of running that system, being there with you. I spent a number of months at that first ZLD in California, actually 6 months, 7 days a week, some days 14 hours a day. It was the first one, it was challenging, there was much to learn, but there's no other way other than boots on the ground to actually get these systems to work properly. You have to be able to do the field testing, look at the model versus what's really happening, and then make adjustments on the fly. That first model, there were some surprises, some things that we had to change. and you have to be able to adapt to those and make those adjustments. We found 4 main components of ZLD that we have found to be successful. We mentioned the one, recycle using coal lime softening. Coal lime softening has been around for over 100 years, 1880s. It's proven, municipalities use it. It's relatively inexpensive to operate. You remove contaminants from the water that you convert to a sludge. That sludge can be easily managed. You can land apply it. Some plants actually take that lime sludge, they use it to sweeten their syrup or add it to their DDGs in the dryers. And now it becomes a revenue stream. Evaporators, crystallizers, another option. That's one you want to stay away from if you can. It's expensive to buy, it's expensive to operate. Typically takes 2 operators per shift, so you're looking at a crew of 9 and a supervisor, versus a simpler system where you'll have perhaps 1 operator per shift. So the crystallizer side is for very difficult water. You've got a system that, very poor water quality, you need that. Discharging the process is almost always part of that package. You're going to take that water, the cooling tower blowdown, or the RO reject, any other stream that would normally be discharged. You're going to reprocess that water through it. You're going to use it in the plant. In some cases, evaporation ponds can be used. Warm climates, you have to obviously be able to evaporate more than you produce, so that's limited to warmer parts of the country. We talked about coal lime softening just a bit. This is a picture of the first system. Outdoors in California, in the Midwest, they're indoors. Very nice to be in a nice warm building working on these. Coal lime softening is it's a proven technology. It's relatively simple to operate and very effective. That is the heart of the design at Patriot. I'm going to talk specifically about Patriot in some detail in a few minutes because that was a system that was very successful, very unique. As we mentioned, the ethanol process can be used as a sink for the plant discharge water, and that helps reduce water usage. That number that we heard earlier, an average of 3, we're able to lower that number, and we'll get into that in just a bit. Evaporated crystallizers, I mentioned, very complex. I believe there are 2 operating in the country. We've been involved with those. Very expensive to operate, energy intensive. And it's sort of the court of last resort. Evaporation ponds for those warm climates.